Gang, Math 6610. Is it comforting that I always remind you what class you're in, just in case you forget? I want to share with you an example that I think is kind of cool. Uh, I think it's kind of cool for a couple of reasons. The main reason is this is data that was really collected. Let me explain the data to you. Um, So, a psychologist at The Ohio State University was interested in the effects of alcohol and mate selection at nightclubs. I will tell you, when I first considered using this example in one of my classes, actually multiple classes, I was really hesitant, pumped the brakes a little because I was afraid I may offend someone because, it seems like we get, offended pretty easily these days. And I would never, ever want to do that. But I think I'm always overly cautious that I don't. But all that said, typically in my student evaluations at the end of 6610, one of the positives that people will tell me is they really enjoyed this data set and the findings, and they wanted to share it with their students. So anyway, as you can read here, the the dependent variable here apparently was, well, the focus was what we call the beer goggles. If I don't know what we call, but they call the beer goggles effect. So she picked 48 students, 24 male and 24 female. She then took groups of 8 participants into a nightclub and gave them no alcohol, placebo drinks, or alcohol-free lager. 2 pints of strong lager or 4 pints of strong lager. At the end of the evening, she took a photograph of the person that the participant ended up chatting with. Afterward, she got a panel of independent raters to assess the attractiveness of the person in each of the photographs. Now, I find that to be kind of weird because for example, my best friend and we have completely different taste in what we would call, I guess, attractiveness. So I don't know really how that works, but I think it's kind of an entertaining example nonetheless. So anyway, the the dependent variable here is that attractiveness scale. Again, out of 100 points, higher score means that you are more considered to be more attractive by the independent raters. And then there are 2 independent variables here: gender, which is dichotomously coded, and alcohol, which is none, 2 pints, and 4 pints. Now, again, the thing I like about this is data that was really collected. This is a study that was actually conducted and is perfect for a two-way ANOVA for obvious reasons. We have a quantitative dependent variable and 2 independent variables, which are categorical. So let's just dive into the problem. I already have the data set loaded into R. So the first thing I would want to do is just get a kind of a glance at the categorical variables. So I would look at gender, and then I would probably look at alcohol. Now, what I'm really doing here is seeing, do I have a balanced design? And I may want to take that just a little further and look at the cell counts. And I can do that with the width function. So I want to aggregate that over my y, which is looks, and by equal, it's just kind of hard to remember. I should have written this down. Gender, alcohol, and then I want the function to be the mean. No, I don't want the function to be the mean. What am I doing? I want the function to be the length. Now, why am I worried about the cell counts? I'm worried about the cell counts because I need to know if I have a balanced design or not. Because remember, if I don't have a balanced design, I need to make that correction, use a type 3 sum of squares calculation method. I have a balanced design. None of that is a concern for me here. So the first hypothesis that I would need to state that I'm going to test, and I'm just going to call this H sub O, the first one, is that no difference in looks across gender. The second, so there I would just say that mu sub F is equal to mu sub M, and H sub O would be no difference in, what do we call it, alcohol. So I believe it was none, a placebo, 2 pints, and 4 pints, a very strong lager. Make sure you keep that in mind. Very strong lager, I assume, affects one differently than Miller Lite. I don't know, so who knows. So we would say that the null for the third hypothesis is the interaction is not significant. All right, so those are the three things that we're going to make decisions about, the three hypotheses, right? So the alternative hypothesis with the first one would be that there is a difference in gender. The second null or alternative would be there is a difference in at least one pair of alcohol. And of course, the H sub A in the last would be that the interaction is significant. All right. First thing I'd probably want to do is run my model, just see what's going on here. And I'm just going to use the AOV command, and I'll do looks over gender by alcohol. Again, I can just run the type 1 sum of squares calculation method because I have a balanced design. And you can see that gender is not statistically significant. So the gender of the participant had nothing to do with mate selection, the attractiveness of mate selection. Alcohol was, gee, I wonder how that's going to work out. And there was a difference in the interaction. So my attention right off the bat goes to the interaction. I really lose a lot of interest in the two main effects right now because most of my important information, it has to do with the interaction between gender and alcohol. So it seems like the levels of alcohol affect gender differently. So I want to dive in and actually see where that's taking place. Now, the main reason I wanted to sorry, I'm not talented enough to speak and type. So the next thing I want to do is calculate my effect size for gender cross interaction of gender and alcohol. And if you remember, that's just the square root. So effect interaction. And this is just the square root of what? The sample size, I'm sorry, the number of levels for factor 1 minus 1, the number of levels for factor 2 minus 1, the F statistic, which is 11.911, divided by the total sample size, which is 48. So the effect for the interaction is 0.7044. Now the reason I want to do that is I want to be able to calculate my power. So go to my F, I want a interactions, priori, so my effect size is 0.704. I want the power to be 0.80. All right, numerator degrees of freedom. Now remember, for this, my degrees of freedom are the gender alcohol, so this will be 2. And number of groups are just 3 times 2 is 6. Calculate the power. I'm expecting we have quite a high power here. So really, that's very cool. Power turns out to be 0.81 if we have a sample size of 24. So, we're going to exceed the power. So I would probably just be interested in doing a post hoc power. And number of groups, total sample size we have here is 48. And I say we're going to be rocking the power here, probably too much, as a matter of fact. Yeah, we have a power of 0.99. So if the null is false, we have a 0.99 probability of rejecting it. So what we get into with high power like this is we could end up with statistical significance, but not practical significance. So we're really going to want to keep our radar on the effect size when we report and interpret these results. All right, so let's close this down. Again, the effect, the interaction is super, super important. So the next thing I'd want to do is I want to calculate, test my assumptions. And again, since this approach falls under the heading of general linear model, I can think of it more broadly and think about the residuals of the model. So the very first thing I want to do is I want to focus on the normality. So there's a really cool plot function. Do I call this model one or model? Just model. Okay. And choose the second level. And I get a QQ plot. Now, how much does this deviate from the line? Well, I don't know. To me, this is a really a subjective determination. So I think what I would do, if I can remember, is dive into the library. What was it? GGPUBR. Yes, and do the GGQQ plot of my model residuals. Now this is going to give me the confidence band, which makes my determination of normality, the normality assumption, much easier to make. So all of the points are in the confidence band. So based on this plot alone, I feel comfortable with assuming normality. Now I'd want to, we're all about p-values in this game. So I would run Shapiro-Wilk. And again, the null hypothesis here is our sample data, namely the residuals, appear to come from a population that is normally distributed. So we fail to reject that and assume the normality assumption is met. All right, cool stuff, right? The next thing I want to do is test the equal variance assumption. So I would just use the plot. Model 1, this gives me a pretty good indication. A little bit of a concern here, but let's look. So I've got quite a bit of variance here, less variance here. The variance at 35. Okay, so yeah, I don't know. I think we might be in a little bit of problem here, but let's see. So we need the library, I need car, and I need Levine test for looks over gender over alcohol. Oh, we don't. Okay, so we can assume equal variances. So life is good, right? If we were, if we were had written a big grant, and it happened to me one time, we wrote a $250,000 grant, and everything went crazy with the data analysis. So if we did that here, we would feel comfortable proceeding with a standard two-way ANOVA and reporting the results to examine the relationship between looks, gender, and alcohol. Now, the next thing I'd want to do is I'd want to dive into the weeds a little bit and take a look at there we go. Oh, I don't know why I put box plots. Freudian slip evidently. Okay, here we go. So let's spread this out a little bit where we can see the so where does the interaction appear to be going on? All right, appears to me there's something going on right here. Look at the difference. And again, these bars right here, or this line right here, the dark line indicates the median. But when we have a symmetric distribution, which it may be argued whether that's true here, this median will be close to the mean. Interesting, the variation in the males who had no alcohol, much greater than the females who had no alcohol. So that's the things I look at. I look at. I always tell my students, even back in my early my intro statistics class, when we're describing data, we look at center and spread statements. So I immediately look at the comparisons of the centers, comparison of the center, red flag right here, comparison of the centers. The next thing I do is I look at the variation. More variation for the male who drank 2 pints than the female who took 2 pints. I'm not even going there. Female for 4 pints, less variation than the male for 4 pints, and a lot more variation for male. So again, a lot more variation uh, for males. Sorry, some of this is just amusing to me. So the next thing I would want to do is to dive into the interaction plot. Again, let's pump the brakes and circle back. Our interaction is statistically significant at the 0.001 level. So there's something happening here that we need to investigate. So the interaction plot, the first thing we'll do, and I'll run this both ways just to see, because that's what I like to do. So I'm just going to put gender first and then put my trace factor equal alcohol. And then I want my response to be my dependent variable. And I want the function to be equal to the mean. All right, we can see where we get our statistical significance of the interaction because these lines would clearly intersect. If I look at the mean of these 3 points, it's going to be right around here somewhere. If I look at the mean of these points, it's going to probably be about right in here somewhere. And then if I look at the mean of come to the center of that line, center of this line, and center of this line, you can see that we have statistical significance clearly for alcohol because of this line right here. And you can see why we don't have statistical significance across gender, because these 2 points will weight more than this 1 point, which is going to pull the mean toward this. So I'm thinking a mean somewhere right in here where I'm hovering my mouse, and the mean somewhere about right here. So there's not a lot of difference there. So it makes sense that gender is not statistically significant. But again, come to the midpoint, the midpoint, the midpoint of these lines. This is causing the statistical significance for the alcohol component. Pictures are great, aren't they? But it sure would be nice to have some means and so I keep wanting to think I called it model one. It's just model, isn't it? So yeah, so here we go. So let's see where, and again, why are we focusing? Why am I just immediately, why am I not concerned so much about this? because again, when my interaction is statistically significant, that's where my attention goes to. So when I come down here, where do we have statistical significance? Well, there seems to be a big difference, sorry, in males who drank 4 pints and females who drank 2 pints. Now, a negative difference would mean what? That the attractiveness of the person who they chose at the end of the night, for males drinking 4 pints and females drinking 2 pints, well, the males uh, didn't score so well on that component. Males, this is interesting, males who drank 4 pints compared to males who drank 2 pints, kind of telling us why the gender wasn't significant. It's all about the pints here, isn't it? 2 pints versus 4 pints, because we're holding kind of constant the gender at male. So males, that extra 2 pints of beer, well, really creates some bad judgment. Even males at 4 pints and females at 4 pints. So we're holding the pints constant and just examining the gender. So males, again, don't score so well. Now we get into a positive difference, actually a couple of positive differences. So females who have no beer tend to choose more attractive mates at the end of the night than males who have 4 pints. And then, as we saw earlier, this is just the same comparison we got up here. It's just reversing. No, I'm sorry, it is not. This is 4 to 2 pints. This is 4 pints to none. So really, 2 pints of beer really doesn't make much difference, does it? It's when the male drinks 4 pints seems to be the main issue. So the attractiveness scale of the person they end up with at the end of the night really seems to slide significantly once the male goes to 4 pints. Because again, circle back, I don't want to be redundant here, but compare male 2 pints versus male 4 pints. Where is it? Here we go. There's a drastic difference there. So the males who drank 2 pints haven't lost their mind yet, but when they go to 4 pints, they have. So anyway, I found this to be pretty interesting. Now, if you're going to write this up, there's going to be a lot to write up. I'm sorry, I wrote this up and I had it. I was going to share it to you so you could just edit it, but I lost the file, but I'd taken a screenshot of it off of a video that I did. So the first thing you would do is write up for alcohol and write up for gender, but the primary thing that we need to focus on here is the interaction effect. All right, gang. Hope you were. It's been 6 or 7 years since I've actually analyzed the data, so I don't know. I was quite quite entertained by it. If you want to know what I'm really thinking. All right, gang. That's all I got. Take care.